day to all. I am Ganesha T from Danasagar College of Engineering. My department is Automobile Engineering. Our project reference number is 47SBE2450 and the project title is Design and Development of Immersion Cooling Battery Pack of Electric Vehicle. And my team members consist of Varun, Mohammad Haya, Sujit and myself Ganesh. It is under guidance of Dr. Jonaris Muthia. Currently, there are lots of fire accidents in electric vehicles. Based on that, we have developed a project on design and development of immersion cooled battery pack for electric vehicle. Objectives of this project are: firstly, to develop a novel advanced battery thermal management system for maintaining the batteries within their optimal temperature range. Secondly, to reduce thermal runaway battery accidents for electric vehicles. Thirdly, to enhance battery cooling by adopting immersion cooling methods. Fourthly, to design and analyze the battery pack and validate thermal efficiency by varying coolant, material flow rate and loads. Lastly, to design and test the battery pack in different conditions. Methodologies of our project are: design and development of BTMS based on immersion cooling, literature survey, study of battery cooling system, design of battery pack, multi-physics thermal analysis, prototype of battery pack, testing and validation, and finally conclusion and documentation. Now I will be running through our work plan of a project. Our project was started in the month of November with a literature survey. Design phase was done in the month of December. Analysis phase was done in the month of Jan. Testing and validation was done in the month of Feb. Fabrication was done in the month of March. Assembly was done in the month of April. Final testing and conclusion was done in the month of May.
Good day to all. My name is Varun and I'll be explaining you the entire design and development followed by the fabrication of the battery pack. This battery pack here, which you see here, is a hybrid cooled battery pack. The terminals of each of the cell are cooled by passing through distilled water through the plates, and the core of the cells are cooled by using a dielectric fluid. To highlight on the word battery hybrid cooling system, the terminals follow indirect cooling followed by the core, which follows immersion cooling. As you can see, we have 4 cells in series and 6 cells in parallel connected in the entire battery pack, which gives you an output voltage of 16.5 volts and close to 7.2 milliampere hour of battery pack. We have used a passive BMS here, which has a temperature probe attached to it, highlighting that the battery pack will be shut off from all electrical connections if at all there is any chance of thermal runaway. Getting on to the cooling circuit, we have a dielectric reservoir here. We have a dielectric radiator here, which is nothing but a heat exchanger. We have a distilled water reservoir followed by distilled water heat exchanger. So the fluid flows from the reservoir of dielectric into the battery pack, cooling the core and back into the reservoir through the heat exchanger. The distilled water is pumped out of the reservoir of the distilled water, gets into the tabs of the battery pack, comes back into the heat exchanger, gets cooled and gets into the reservoir again. Getting on to the actual electrical connections in the battery pack, we have an SMPS which is used for charging, followed by a boost converter which boosts up the voltage as per the battery pack's requirement, and a bulb and a series of 3 bulbs in parallel which are used to vary loads.
Good day to all. My name is Mohammad Haya and I'll be talking about the fabrication of the battery pack. Our battery pack, it has tap cooling as well as dielectric fluid cooling. And the tap cooling, it uses cooling plates which is 12 mm thick and 12 mm thick at the top and the bottom. And to make an enclosure, we have 2 mm aluminum plates which enclose all around the battery pack. First, on the 12 mm plate, the holes for the batteries were drilled, and then through holes were drilled from the lengthwise for the coolant channels. And also, we drilled holes along the perimeter of the battery pack and threaded those to attach these fasteners. And to make the battery pack hardened as well as electrically non-conductive, we have done an anodization process with sulfuric acid of 25 microns, and it was let to harden in hot water for 30 minutes.
Good day to all. My name is Sujit. As you can see, the test bench is running live. It's currently the battery pack is running at 2C rating. and the dielectric fluid over here is running at a flow rate of 6 meter per second, and the distilled water is running at 0.5 meter per second. The same setup was simulated in an open source software which is SimScale, and the results were tabulated and concluded.